Hi everyone, welcome to Calculus and Vectors, MCV4U. Today we're going to get started with 1.1, radical expressions. Our learning goal today is to simplify radical expressions by rationalizing denominators. So first we need to understand what radicals are. Okay, so we have so n is called a index number. M is an exponent. And A, we call it a radicand, or we could call it as a base as well. And this is a radical sign. And if I have to change this into an exponent form, so we have a base, and the index number goes in the denominator, and the exponent goes on the numerator. Okay, now, so our first one of the rules for the radical is that when you have a same base of a square root, it cancels out and you get 2. So the reason behind it is because there's invisible 2 here. And if I have to put it in exponent form, it will be a to exponent of 1 over 2, right? Because there's invisible 1 here. And then times a to 1 over 2 is equal to, so when you have a same base, you add the exponent. So it becomes a to the 1. For the second rule is that when the index number and the exponent is exactly the same, they cancel out and you get the base by itself. Again, keep in mind that the exponent can be under the square root sign or outside the square root sign. Just remember that exponent always goes at the numerator. Also keep in mind, if the index number is even number, then the base, the radicand, must be greater than or equal to 0 because you don't want a negative under the square root sign, right? So then it's going to be an imaginary number. So keep that in mind. Okay, so let's start with number 1, simplify. So it's a square root sign. Okay, so there's invisible 2, and you have a same base, so that means it's going to be 3. Okay, again, the reason behind it is the exponent form will be 3 to the 1 over 2 times 3 to the 1 over 2. And you add the exponent when you're multiplying the same base. Now, so letter B is a tricky one. So it looks as if it's already simplified, and there's not much you can do if I were to put it in a exponent form, right? So one of the ways you could do is you're going to split 5 into make it a same index number. Okay, so what I'm going to do is 3 cubic root of 7. So instead of 5, I'm going to split it so that it has the same index number times cubic root 7. So then the exponent here must be 2 because you add the exponent to give you 5. Okay, so what you notice is that we have a same 3 and 3, so it cancels out. So I have 7 cubic root 7 squared. And I can further simplify by applying this 2 under the square root sign, so 7 squared. So it's 7 cubic root 7 squared is 49. Okay, so that's the most simplifying simplifications that you can do when you have a big exponent. The next thing is conjugate radical. So conjugate radical is when you have a same base or the radicand, the only difference is that they are in opposite sign. Okay, so again, same radicand, square root A, square root B, but the only difference is one is plus and 1 is minus. Again, you're pretty much writing exactly the same thing as you see. Okay, the only difference for conjugate is this sign. Okay, so why do I need to know the conjugate radicals? So when you multiply the conjugate radicals, it's like a simplification of doing a short version of FOIL. So if I were to multiply these two, so for example, a square root b times a minus square root b. So first of all, what you would do is you're going to FOIL. So it's like front, outside, inside, last. So it's a really long way, which is a squared plus a square root b minus a square root b minus b squared. So you will notice that these two cancels out. So you get a squared minus these two cancels out, right? The reason behind it is b is 1 over 2, right, in exponent form. So 1 over 2 times 2 is 1. So it's a squared minus b. So this is a long way, but we want to shorten that process. So the conjugate radical, you just multiply the same number. So a times a is a squared, and square root b times square root b is b, and positive times negative gives you negative. Do you see that? Okay, so let's try the next one. So same thing. These first two terms, when you multiply it, it becomes a squared, and square root b times square root b becomes b, minus c times c is c squared, and square root d times square root d gives you d. Okay. Much easier than doing long way of foiling, and this way you get rid of the radical sign. So for each expression, find the conjugate radical. So for number 2a, it would be 2 square root 5, exactly the same, but it's going to be minus, and then exactly the same again, 3 square root 7. Again, 2, same number, but opposite sign, and square root 3. So this will come in handy when you are rationalizing to get rid of the radical signs, when you have an expressions like this. So this is a simple rationalizing denominator. So as you can see in this example, we have a radical square root c. So what you're going to do is, to get rid of square root c, you're going to multiply top and bottom, numerator and denominator, by that radical only. So square root c times square root c, and when you multiply these two, it becomes c. So it's a square root c over b times c. So it's okay to have a radical in the numerator. Our main goal is to get rid of it in the denominator, so that we have a rational number than irrational number in the denominator. So number 3, it says rationalize the denominator. So we have square root 5 here. So I'm going to multiply top and bottom with square root 5 and square root 5. So therefore, the numerator is going to be 2 square root 5 over 3 times square root 5 times square root 5 is 5. So I can simplify further. So 2 square root 5 over 15. Okay, so that's it. Now, number 3b, so we're going to multiply. So this time, you notice that we have a radical, but also an expression. So once you see an expression, plus or minus, you are going to find the conjugate radical. So it's going to be 2 minus 3 square root 5. Exactly the same number, just opposite sign. So whatever you to the bottom, you got to do to the top. So 2 minus 3 square root 5. Okay. So I should be going vertically down, but I'm just out of space. So for the numerator, it's going to be, you're going to multiply, do the distributive property. So 4 times 2 is 8 minus 12 square root 5 over, so again, the perks of doing conjugate radical, you just multiply. 2 times 2 is 4, minus 3 times 3 is 9, and square root 5 times square root 5 is 5. So therefore, 8, 12 minus 5 over 4 minus 45. So then you can simplify further. So then 8 minus 12 square root 5 over negative 41. Okay, so you can factor, you will notice that the coefficient 8 and negative 2, it's factorable by 4. So if you like, so you can factor 4 bracket 2 minus 3 square root 5 over 41. So negative could be at the bottom, top, or in the middle. Okay, good. Now the next type of question is finding equivalent expressions. So equivalent expression means that you could rationalize the numerator or denominator depending on where the radical is located. And keep in mind that you have to state the restriction for the denominator because you don't want the denominator to equal to 0 or else it will be undefined. So you want to let the whole set of the radicand, whatever it's under the square root or the radical sign, equal to 0. At the end, you're going to find the restriction, a number that cannot equal to 0. So number 4, it says find equivalent expression by rationalizing. So they don't tell you to rationalize numerator or denominator. You decide depending on where the radical is located. So number 4a, so we have to rationalize the denominator. Okay, so we're going to multiply. In this case, I'm going to multiply the conjugate radicals. So it will be square root of x. So opposite of minus, it will be plus 1. Square root of x plus 1. Okay, and then, so don't forget, because we have two binomial, you gotta do FOIL. Front, outside, inside, and last. So it will be x square root x plus x minus square root x minus 1 over, now square root of x times square root of x is x, and then minus 1 times 1 is 1. Okay, and then let's simplify this further. So we have a like term over here. So these two, I'm going to group them together. So x square root x minus square root x plus x minus 1 over x minus 1. Just got a little bit of space. And what I'm going to do, I'm going to factor the first two terms in the numerator. So we have a common factor of square root of x and then x minus 1, and then plus x, so I'm factoring 1, which is just x minus 1, x minus 1. So you will notice that I have a common factor of x minus 1. So let's group x minus 1, and then square root x for this one, and plus, there's invisible 1 here, plus 1, and x minus 1. So then you're going to cancel x minus 1, and I'm left with square root x plus 1. Now keep in mind, like I said, when you're finding equivalent expression, you have to make sure that denominator cannot equal to 0. So look back to your denominator and look at the radicand sign. Okay, so in this case, x, so look over here, x cannot equal to 0. But also, you have to keep in mind that x cannot be equal to 1. Why? Because square root of x minus 1 cannot equal to 0, the whole equation, and then square root of x cannot equal to 1, x cannot equal to 1, right? So the opposite of square rooting is squaring. So that's why you get x cannot equal to 1. So therefore, comma, x must be greater than or equal to 0, and x cannot be 1. The reason behind, again, the index number is an even number. Do you remember, if the index number is even, x must be greater than 0. Okay, the next one is square root of x plus 9 minus 3. So in this case, we have to rationalize the denominator. So I'm going to multiply, again, it's an expression. So square root x plus 9, same number, but opposite sign, plus 3. So whatever you to the top, you got to do it to the bottom. So x plus 9 plus 3. Okay, so square root of 9 times square root of 9, it becomes x plus 9, and then minus 9. So I'm just showing you the side work, x plus 9 times x plus 9. So it's like x plus 9, 1 over 2, times x plus 9, 1 over 2. So when you multiply, you add the exponent, 1 over 2 plus 1 over 2, it becomes 1. So this is the beauty of conjugate radical over x times x plus 9 plus 3. And don't forget, you're going to put a bracket, right? Unless you do distributive property. And then you'll notice that plus 9 and minus 9 cancels out. And then you'll also notice, because in the numerator, I'm left with just x. So x and x cancels out. Okay, so if I have to show you, plus 9 minus 9 cancels out. It will be x plus 9 plus 3. And then they cancel out. Okay, so my final answer is 1 over square root x plus 9 plus 3. Okay, so in this example, it's okay to have a square root, the radical in the denominator, because we started off with radical in the numerator. Now, don't forget the restriction. It's going to be x plus 9 greater than or equal to 0. That's the idea behind it. because the index number is even, so you don't want the radicand to be less than 0. So x is greater than equal to -9. Okay, good. So x is greater than or equal to -9. You also don't want x cannot be equal to 0, because if it were 0, then it's going to be square root 9 minus 3, 4. So x cannot be equal to 0, going back to my original denominator. Okay.